Okay, so exponential functions, differentiation, and integration. We have done no differentiation of exponential functions until now, except in, you guys did have it show up in the Khan Academy stuff, right? Just a little bit. Our book separates it. They didn't. They just put all the differentiation together. And I know other calc books don't separate it also. And I don't know why ours just does and doesn't. I don't know the theories behind that. But anyway, so differentiation of the natural exponential function. Natural means it's base what? E. Okay, so the inverse function of the natural logarithmic function is natural log of x is called the natural exponential function and is denoted f inverse of x equals e to the x. And you guys know this. We know that we can go from here to here. Yes? Yeah. Okay, so we have y equals e to the x, which that is x is equal to the natural log of y. That is changing from one form to the other. In pre-calc, when we solved these things, we switched forms. It was when I got to the point to say what next, you switched forms. So if I have 7 equals e to the x plus 1, x plus 1 is an exponent. How would I solve that? Remember?
Well,
can you get to the x?
Yeah. No.
No, not in this form. So I have to switch it to logarithmic form?
Yeah.
So since I'm e, we're natural log. So we have the natural log. We take the natural log of both sides.
Yes, okay.
Remember doing this?
Yeah.
Okay. Now our exponential rules, not exponential, logarithmic rules says an exponent goes where?
Into the front.
Into the front. So we have the natural log of 7 equals x plus 1, the natural log of e. Now, those parentheses around that x plus 1 are pretty important because that is one thing at that point, correct?
Yeah.
Okay, now what is the natural log of e?
1.
It's 1. Because what's the base of natural log?
E.
E. So remember if I have log base e of e to the x, the answer is x.
Yeah.
Log base, whatever base of that to the x is what?
1.
Oh, yeah, but x in that case, but the exponent. So this is just 1, and so now I have the natural log of 7 equals x plus 1. Now my parentheses don't matter, and I'm solving for x, so you would just what?
Add over 1.
How about subtract over 1?
Subtract over 1.
So x equals the natural log of 7 minus 1, or you could put negative 1 plus the natural log of 7. Some people like to keep that natural log at the back. I don't care, and it's not very big deal as long as you're putting parentheses around the 7.
Yep.
If you don't put parentheses around the 7, you're not quite sure what you're taking the natural log of, correct? Your book won't put parentheses around those all the time. And so we've learned that it's important for us to put them there so we know what is connected to the natural log and what is not. Okay, so this was an exponential form, and we put it into logarithmic. That's that 1-to-1 that we used. Okay, so now the next one is in logarithmic. We're going to have to put it into what?
No.
Exponential? But yes, it is the natural log. It is natural. Okay, so we're solving for x. We can't get to the x because it's inside the function, yes?
Yeah.
So what's the base of natural log?
E.
Okay, I'm gonna do it one way, and then I'm gonna show you, like, if you look at Calc Chat, how they're going to do it. And I don't care either way you do it. Do the way that it makes sense to you. So the way I'm gonna do it first is the way it makes sense to me. Okay? So this would be e to the 5th equals 2x minus 3. Correct?
Yeah.
So then I would add 3, divide by 2. Is that too quick? Was that too quick? Okay. So x equals e to the 5th plus 3 over 2. And I'm done. Okay. Now, in Calc Chat or the textbook, when you hit show me how to do it, they are going to say they raise it to the power. They take both of them to the power of e. And it uses the properties rather than the inverse part of it.
That looks way more confusing.
To me, I don't like it. So where I have e and e as my bases, yes?
Yeah.
So that makes this 2x minus 3 equals e to the 5th. So do I have the same thing?
Yeah, it's just
Yes.
more.
I like this method.
Yeah, if I saw that, I'd be like,
Especially when you have like log base 7 of 2x minus 3 to the of 5. And they do this method. This isn't an e, it's a 7. It is so much easier to just do 7 to the 5th equals 2x minus 3, isn't it?
yeah.
Yeah.
So whatever.
Whatever your base is. Because this...
Yeah, but like I'm saying for the 5, whatever number's out there, that's going to be the one that it's 2. If it
Yes.
was like a 6,
Yeah.
it'd be like.
Yeah.
Either.
Because you have to change your input and output.
Mhm.
So you have to switch sides here.
Yeah.
So it's your base to that power.
Okay.
So I prefer the boxed method. I will tell you, if you look it up in Calc Chat, they're going to do the other method. But every single time, this side is going to reduce to the exponent. Because, what rule is that? It's not 1-to-1, it's inverse property. Okay, this is the inverse property without raising it to the power. Like, we are doing the inverse property because we're changing forms. We're just doing it a different way. Okay? Okay, so this is the graph. I don't think you need to, you know that's what an exponential function looks like, yes?
Yes.
We all know that because anything to the 0 power is 1. So they all go through 1 and it increases. We know that. We know that if I take e to the a times e to the b, it's e to the a plus b. We know if I would divide, I what? Subtract. These are all things we already know. Just putting them out there. Okay, so here is your derivative rules. So number 1 is specific. Number 2 is the general that works for everything. Just like we did the natural log. I gave you one of them was just for x and the other one was for everything. So if I'm going to remember one of these, which one is it going to be, 1 or 2? 2. Got me? Okay, so the derivative of e to the x is e to the x. So the second rule right here is the derivative of e to the u is e to the u du dx. Well, what does du dx mean? E to the u
It's just.
u prime.
Yeah.
Doesn't du dx mean the derivative of u? Yes. Okay, so we have the derivative of, and this is missing, this should have brackets on it, shouldn't it? Okay, so again, I'm going to put it in u du, u du, u du, because guess what's going to happen from now till the end? U du, u du, and I'm going to put some other stuff into it too. So, what is my u?
2x minus 1.
So u is 2x minus 1,
Prime is 2.
and u prime is 2.
So it would just be e to the 2x minus 1, 2.
How about 2 e to the 2x
Oh,
minus
yeah.
1? That would look much better, wouldn't it?
Yeah.
I knew what you were getting at. You guys want to try the next one on your own? That is negative 3 over x, correct? Okay. Do you guys agree?
Yep.
Ainsley, you agree?
Yeah, I was slow on it.
Oh, I'm sorry. But, and I just wrote this negative 1 because we know by now we have to write it to the negative first, correct? You guys are doing so many more things just immediately where before you had to like convince yourself that's what you're supposed to do, right? So, you just, once you decide you're just going to you do you, you do you, you do you, you do you. That's what it is. Okay, so, I mean, all we have are examples, so.
Is this all we're doing today?
Yes. Now, could you have the chain rule go in there? Yes. Could you have the product rule happen?
I hope
Yes. I think you have the product rule right there. How do I know that's the product rule? Because it's the product, right? Okay. So, what's our product rule? Do you remember that?
F prime of G plus G prime of F. Right?
Yep.
Okay.
I would write F prime G, F G prime, just because I want F and G, but I mix them around all the time anyway. Okay, so F is x squared, right? And G is e to the x.
Yep.
Okay. So the derivative of x squared is
2x.
2x, and then e to the x plus well, what's the derivative of e to the x? E to the x. So it's just x squared e to the x.
You can take out the e.
And we can factor out the e and an x. So I could have x e to the x 2 plus x.
Yep.
Okay. Now, where would that be valuable? If I needed to plug in and find the slope, which you guys forgot again how to do on the the test, that last problem, you're just plugging in the x and the y, right? If I ask you for the equation of the tangent line at 1, 3, then I would find m is 1 e to the 1, 2 plus 1. So it would be e.
Yeah, I kind of looked at it and I was like, we're going to wing it.
Okay, but what did I tell you? Once we had that question that one time on a test, I said it will be on every single test. It will be on every single thing you ever do with calculus. It will be there. Because that is, okay, guys, derivative is the slope function of a function. Like, that's what it is. So they're going to continue to ask you the question. Right?
Well, they just need to stop.
Oh, they just need to stop. Well, they're not going to. Okay, so we had to do the quotient, the product rule. Now we're going to have to do the what rule?
Quotient.
The quotient. And how do I know it's the quotient?
Because you know it's the quotient.
Because you know it's the quotient. There's a division. Now, are we past the point of needing to write down u prime, or do we still need to write u prime?
It doesn't matter to me.
You tell me.
Sometimes I do it, sometimes
Okay, so you guys tell me what you want me to write. Well, first of all, what's the rule?
Isn't it just over 2 or over g squared?
F prime g minus g prime f
G squared.
over g squared. Yes. I was like, I don't know what you're really talking about. Okay, so do we need to write, well, what's the derivative of f? Can we do it in our head yet?
Is F the top one?
Yes.
And wouldn't it be...
Okay, so we'll put f over here. So that would be, u would be what for f?
3x?
3x. So u prime would be 3. Okay, so the derivative of that is e to the u prime, right? So it'd be 3 e to the 3x
Yeah.
times the denominator. So e to the x plus 1 minus, okay, no, g. Well, I don't know. I don't think we should have to write down g. What's the derivative of the denominator?
1. Well, I thought you...
What's the derivative of e to the x?
E to the x.
So just e to the x. Times the numerator.
Yeah.
All over e to the x plus 1 squared. Okay, now we've learned not to distribute because we probably can factor out, right?
Yeah.
So what can I factor out?
E.
To the,
X.
nope,
3x.
e to the 3x. See that?
Yeah.
Okay. So e to the 3x. So then I would have 3. Can't I just multiply this?
Yeah.
3e to the x plus 1 minus e to the x over e to the x plus 1 squared. Okay. Oh, I really almost did it. I really almost did that. That was bad. I think we could...
I don't see anything else that we can...
I do, though, because this, isn't this e to the x times e? Because I'm adding, when I multiply, I do what? Add exponents? So what, this would be 1, so this would be e to the x plus 1, wouldn't it? Now, you wouldn't have to do this, but I just saw it. My brain goes, oh, wait a second. So if this is e to the x times e to the first, can I factor out an e to the x?
Yeah.
Yes. So I have e to the 3x times e to the x times 3e minus 1. Now we're just doing more flips, right? We're just
probably wouldn't do the bottom
okay.
because that did not come in.
But now, since I have these, when I multiply, I do what? Add. So it'd be e to the 3x plus x, which would be e to the what? 4x. So e to the 4x times 3e minus 1 over e to the x plus 1 squared. Now I want to ask you, okay, we did this because I said, ooh, but wouldn't it be better to plug it in here than here?
What are you
Why?
asking?
Would you rather plug in and find the slope, which I know you guys love to do? Would you rather do it on the box or the arrow?
Probably the box.
Why?
Because it's smaller.
There's less x's, right? So can those extra flips and twirls that we can do with our math help us out?
Yes.
Yes. Do we need to start looking for those?
No.
Yes.
I guess.
Yes. Okay. Because we should be able to identify when you're adding exponents, that means you were multiplying. We should be able to tear those apart as well as put them together. And that's just something we have to train our brain to see. It's not just going to go poof, right? It's going to take a little time. Yeah. And so when you got an answer and you're like, oh, well, I've got this answer I got this as my final answer, but that had 3 more steps for them. Let me look and see how they did that. And if you watch somebody else do it enough, are you going to start seeing it on your own? Yes. Now, we learned yesterday, or the other day, Ainsley would come up and say, how did they do that? I'm like, I don't know why they would do that. And I would do the derivative or the integral, and I would put it into the integral calculator, and I would get exactly the same answer as they did. But in the textbook, they did more flips and twists, but I figured it out, but we were also right. Does that make sense? So we're not meaning we're wrong. It means the person that wrote the answer key to the textbook really liked to do some math gymnastics. Like they were a tumbler. Does that make, is that analogy? Like the Summer Olympics is coming up. It'd be like me going out there and doing a cartwheel and Simone Biles going out there and doing her 50 million twists and flips, and that's what it is. Got it? So you better get your back handspring. Okay, find the relative extrema. Guys, how do I find an extrema for chapter 2? Find the what and set it equal to what?
Find that, if you set it equal to 0.
Uh-huh.
You find the derivative.
Find the derivative and set it equal to 0, right? The extrema happen at the zeros of the first derivative. Okay, so, that was a long time ago. Chapter 2. Okay, so we need d dx of x e to the x. So that's a product, isn't it?
Yeah.
Yep. Okay, so derivative of x is 1 e to the x plus, well, the derivative of e to the x is
E to the x.
e to the x. Okay. So we need to set this equal to 0. I'm assuming you want to factor out an e to the x.
Yes.
So I have e to the x 1 plus x equals 0. So I have e to the x equals 0 and 1 plus x equals 0. Am I going too fast?
No.
Ainsley? Okay. So x equals -1. I did the easy one. You guys get the hard one.
Wasn't e to the x equal e to the x?
Question for you.
It's just e to the...
Can any power
No.
give you a 0?
No.
No.
So it's e to the x.
So
Or 0. It's e to the x.
like
Oh, it doesn't.
it's not in the domain or in the range, right?
So it's just x equals -1.
Right. 0, since 0 is in the y, we'd say not in range. Because what does an exponential function look like? Is it ever 0? No. Okay, so are you going to have extraneous solutions?
Yes.
Yes. Do you have to know which is good and bad?
Yes.
Yes. So the extrema happen at -1. Now, if I wanted to find what if I ask you, is it a max or min? How do I find that? Do you remember? I do intervals. So where's my interval always start?
-1.
No. It's clear over there.
Negative infinity.
Negative infinity to,
-1
and then -1.
to positive infinity.
Okay, so any number, right?
Yeah.
Okay. So
Do we have to do this on homework?
I'm not sure if you do or not, but you may. Okay, so I pick a number. What number do you want less than -1?
-2.
-2. Okay, so we're going to put it in here.
And then we just
Now, a negative exponent makes it a reciprocal, yes?
Yeah.
So I'm going to have -2 over e to the second. Is that going to be a positive or negative solution? Negative. Okay, give me a number greater than -1.
2.
2. So that's going to give me 2e to the x. Is that a positive or negative? Positive. So this graph is, so here's -1, yes? And it's negative down here and,
Positive up there.
wait, it's decreasing, right? Not negative. Wait, did we put it in the wrong one? Are we supposed to put it into the first derivative? No, because this says the graph is,
Pretty sure we did it right.
you think so? So this would be,
I'm trying to remember.
this would be negative,
What's that?
and this would be positive. No, you put it into the derivative. Okay, so this is negative, this is positive, so that means the graph is going
Up and
down and up. So it is a what? Relative minimum. Because it's going down and then up. Now, it happens if we put these into the derivative or to the original, we still get negative positive. I need to look that up. Oh, I cannot believe I'm a failure. I'm a failure. Wasn't that chapter 2 we did those? Or was it chapter 3? It was a long time ago.
Chapter 3.
Chapter 3?
I think.
Yep, it was chapter 3. Okay, so, because I hate that my brain just totally forgot that. It's 3-1. Okay, so we found, you found the zeros. Okay, they put it into the function. They put it in the function. But either one, we got negative and positive, right? So, but it means we put the zeros of the first derivative into the function. So it doesn't mean above and below the x-axis. It means it's decreasing and increasing. So that I was doing two things at one time. That wasn't working very well. Okay. Tangent line. Oh, look at 1-3. So find the equation of the tangent line. So I first need to find the what?
Slope.
Nope. Slope function, which is the
Derivative.
derivative. She's like, I can't say it. So d dx of 2 plus e to the 1 minus x. Well, the derivative of 2 is 0, so that's out, right? Mm-hmm. So u is going to be what on that e? What's the exponent? 1 minus x. So u prime is going to be -1. So the derivative is going to be negative e to the 1 minus x.
Yep.
Okay, so now I need to find the slope. So the slope is f prime at 1. So negative e to the 1 minus a -1. So it would be negative e to the... Oh, wait. It's not a negative. We're not plugging in a -1, are we? Sorry. You guys should have caught me. 1 minus 1,
Yeah.
which is negative e to the
The
0, which is... What's anything? Yep, 1. So my slope is 1.
Okay.
So now I'm going to do y minus y equals m times x minus x, right? So y minus, what's my y? 3 equals m.
1.
X minus x.
Oh,
1?
1.
No negative 1 up there.
I don't know.
So then add a 3, right?
Yeah.
And distribute your 1. So y equals x plus 2. So again, the problem you guys always hate, but you've done it the entire book.
I just forget the y minus y equals, and I don't know why.
We've done it forever. I should put my 1s on there, right? Now, at this point in the textbook, I'm saying, here's a new rule, do everything we've done with it before. Here's a new rule, do everything we've done with it before. Does that make sense? Like, we did the quotient rule, we did the product rule. Can the chain rule apply as well?
Yeah.
Yes. And tomorrow is integration.